Hi, I'm Elaine. Welcome to my podcast channel.
Good afternoon, George. How are you doing?
Oh, I'm fine, thanks.
So would you like to start off with self-introduction? Which field of math or what do you specialize or, you know?
Okay, I am professor emeritus of mathematics at UBC, and my field of specialty is connected with differential equations, in particular symmetries and differential equations.
Mhm.
Written several, co-authored several books on the topic.
Yeah.
And incidentally, some of them have been published, all of them have been also published separately in China.
Wow.
And also translated. One has been translated into standard Chinese.
Wow, that is amazing. Do you know any Chinese? You're like a little
No,
bit.
I'm afraid I don't. Even though I've been there many times, I don't know any Chinese.
Maybe counting the numbers a little bit.
No. I did it a little bit at one time, but not now.
Yeah. Yeah, I think Mandarin or Chinese, it's a pretty difficult language compared to English. So, yeah.
It's the alphabet problem.
For sure. C- just a question about the UBC's math program. What do you think really stands out part of the UBC math department?
Well, from the point of view of students, is that the UBC has a very good honors program. So students who want to go on into a research environment is very, very strong. It is one of the best 25 in mathematics. Is one of the best 25 universities in the world, in fact, and one of the two best in Canada.
Yeah.
And so you can do applied mathematics or pure mathematics, or there's also separately a statistics department. There's a lot of math going on in the computer science department as well. And you can do a degree in math in science, arts, business school, or engineering.
Yeah. That is really interesting. Yeah.
And most of the graduates who do the honors degree will go on to graduate school and onto their PhD. And after that, most of them go. In the old days, they became academics, but nowadays they most go into industry. They work for companies like Microsoft or Google, and in fact, the richest graduate of UBC was one of the starters of Google. He was an honors math grad. In fact, he's the sixth richest Canadian. He got in his background honors math at UBC.
Yeah.
And so he is one of the. If it went, Google wouldn't have started if it weren't for him.
Yeah. It's always the Canadians, the best people in the world. Yeah.
Oh, I don't know about that. I wouldn't go so far as to say that. There's no one the best. I think the best is everywhere.
Yeah. Yeah. Canadian UBC is a very good university for sure. It's like, yeah. Do you think the overall atmosphere at UBC, like how long have you stayed at UBC?
Okay. Well, I was actually an undergraduate student at UBC. I started as an undergraduate student at UBC. I'll tell you how many years ago it was. It was 62 years ago. I started as an undergraduate student.
It's like a home for you.
Yes, and then I went for my graduate working to a place called Caltech in Pasadena, California.
Really famous, I know.
And then, but after I finished there, I went back to UBC and became professor there. And eventually, I was head of the department for a while at UBC as well, the math department. But I've also been associated with many other things at UBC.
So do you think the faculties are nice, or are they very, very serious and then they do things? Are they more serious, you think, or they're more casual? And
you're making when you say that we're more serious, you're making a comparison with what, you see?
More serious, maybe a comparison with, these standard Chinese schools, like Chinese high schools where teachers are so serious and so.
Oh, I see what you mean. Oh, well, okay. Well, no, it's not. I know from my experience talking to students in China about the school and how rigid it is in the sense that you have no time for play, basically. you're studying for your equivalent of the provincial exam there,
Mhm.
and you start on that, maybe even grade 10, but grade 11 certainly you're working almost full time
Mhm.
on preparing for these exams. So everything's geared towards these national the GOCO, right?
Yeah.
The GOCO. So and so the students are have no chance to broaden themselves, in fact,
Mhm.
and that's very different. So now you're comparing a high school in China with UBC, or a high school in China with a high school in Canada. Which kind of
This
comparison?
rigorous, because like universities in China, they are mostly quite chill. So I'm comparing this rigorous system in high school China to this more rigorous system compared to Canadian high school. How can I say this? University. Basically comparing high school, Chinese high schools to Canadian universities.
Okay, no, it's much more serious in the Chinese high school,
Okay.
and the university is not does not have a rigid attitude and is quite many ways flexible.
Mm.
And in China, when you go to the comparison between universities is very important, because in China, when you go to a university, you go into a particular program, and
Right.
once you're in that program, it's very difficult to change.
Yeah.
In fact, a common question I get when I talk to a first-year class in China,
Mhm.
this is in the Shanghai area,
Yeah.
the question I often get, usually from boys, by the way, they say, "How can I get out of math?" They say they were admitted to the
Wow.
university in math, but they want to go do some other subject. But
Mhm.
it's not. But it's very difficult to make such a change. Whereas in North American universities,
Mhm.
and I'll say UBC in particular, as long as you're qualified, you can make a change from one field to another.
Mhm.
And many students do. They not only change fields within a particular faculty, but they change from one faculty to another.
Wow. And how big is this change as you say the
It's not
change?
it's not such a big change for the student. No, you get, because your credits will transfer over to the faculty you switch to in most cases.
Mhm.
For example, one of my sons went to UBC.
Mhm.
He was originally in science for the first 2 years, and
Yeah.
then he switched to arts.
Wow. So it's a really big turn.
Oh
So,
yes, it's not uncommon.
yeah. Like I've heard of people in maybe American universities, they first specialize in history and then they just turn to math. So
It's the same at UBC.
yeah.
The Canadian universities are. I can't speak for all Canadian universities, but certainly at UBC, it is that way. There's a flexibility.
Yeah. And I think at university, the workload's like more intense compared to high school workload. Would
Okay,
you say?
there's different kinds of programs at the universities. So there's,
Uh-huh.
I'll say, more serious programs and less serious programs.
Okay.
The honors program is much more serious. In
Hmm.
the case of science, you have to take even more courses, but you take harder courses. In the
Right.
case of mathematics, the separate honors courses, starting from first year, actually. And so these are much more challenging. And of course, you are with peers like yourself in the class,
Hmm.
uh, and which have similar interests. So the honors is a very is a much more difficult program. But if you want to get on into research, not just in mathematics, other fields, and the honors programs in every field are much better than the what they call majors programs or minor programs. So you can do a minor in a subject, a major in a subject, or honors in a subject.
I've heard that Waterloo or of course a Canadian university
Yes.
has a super um heavy workload. Would you compare this Waterloo's workload with UBC's
Well,
workload?
I know
Like,
Waterloo well because I used to go there 2 or 3 times every year. I was
right.
involved with some national things
Mhm.
with Waterloo. But anyhow, UBC is a stronger, is a more intense. The math program is more intense at UBC than it is at Waterloo,
Wow.
and it's a better, certainly a better program, because UBC has a much stronger. If you're a serious student, UBC has a much stronger faculty than Waterloo. You see.
Wow.
it's very important that you have that the faculty who are teaching you as an honor student are very well-known researchers, because when you apply for 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 anything to do after you finish university, you need letters of reference. And
Right.
it's the better known someone is, the more significant would be the letter of reference, if it's a good letter of reference, you see.
Right.
And don't get me wrong, Waterloo's a very good university, but they get very good students. But nonetheless, the total number of honors grads now from UBC is actually not that much different from Waterloo now.
Yeah. And also UBC is better than U of T. Is that true?
No. I would not say that at all.
Oh.
U of T and UBC in mathematics and in most subjects are by far the best two universities in Canada. So University of Toronto is a very good university, but some students feel that at U of T they don't get enough individual attention. Some students have said that. Again, it's a function of the professor, and the UBC has had more programs, this is a closer relationship between the faculty and the students.
Right.
That is, although this might have changed now in Toronto. But when I was actively involved, and I think the students found it friendlier at UBC.
Yeah, so I noticed that you traveled around the world with like all the universities. I think you know a lot of universities. So which university do you think has the smartest and most comical students?
Comical?
Yeah, comical, like very casual and chill, like they're just very open and
Oh, well, that's a function. First of all, it's generally a function of the individual student. For example, I know students in China who are very comical and very individualistic.
Really?
Even despite the system, there are many students very individualistic. In particular,
Really?
yes, and at the university level,
Wow.
particularly female students. In fact, I was so impressed with some of the female students I came across in China.
Really? Like what?
Chinese female students compared to Chinese male students, and you compare Caucasian female students to Caucasian male students, the Chinese are far superior.
Really?
The
Smarter?
ratio of women who are get involved and are very good students, the ratio of Chinese women to Chinese men is much higher than the ratio of Caucasian women to Caucasian men.
Wow. How do you know the ratios exactly? Is it from your sample?
Oh, I'm involved with mathematical competitions and for many years, and I'm talking about the top 100 students.
Okay.
What fraction are women and what fraction are men? So you very rarely would find a Caucasian woman doing well, but a woman of Chinese descent relative to males of Chinese descent, the ratio is much higher.
Wow, that's amazing to hear.
It's very noticeable. And also, when I went to classes in China, the women spoke out more than the men in the classes, undergraduate classes I've spoken to, whereas that's not true in North America. Women are very. It's a bit of a paradox in a way, because politically, women in China are not treated well. In the top end of China, there are no women. Okay, that's not true in Canada. But when it comes to the university and the people I come across with, women it's so impressive.
It's great to hear.
Women.
Yeah. Have you visited Japan or Korea?
Yes, I've been to Japan, China many times, and different parts of China, Taiwan, Hong Kong, and Japan. Yes, Japan I've been to, in particular the Tokyo area. I've been other parts of Japan, but not like I've gone to Japan for mathematical reasons and other reasons as well. Because my family background, Japan played a role in my family background, and of course I've been to Russia, Ukraine, and Eastern Europe, all over the world. I've given lectures all over the world.
Right. And do you think, so amongst all these universities that you travel to, like the whole world, you think Chinese women are the smartest mathematically?
No, I didn't say that. I just said the ratio of women to men That was not. I wouldn't go so far as to say that. But where you see strong mathematicians in countries, relatively speaking, I would say China certainly would be the case, and Russia also is very impressive that way. Ukraine is also impressive for the number of women relative to the number of men doing well, and but it's and Italy also. But in general, in Western countries, no. The number of women doing well relative to the number of men is not. The ratio is too low.
Yeah, but that is really surprising to hear. So the ratio between women and men in China is way higher. And do you mean basically the same phenomena goes for Korea and Japan? So basically the Asian countries?
I don't know. I wouldn't say that for necessarily for Korea and Japan. I wouldn't necessarily say that. I don't. I've not been to Korea, but again, I look at the students that I've come across in the schools in the Vancouver area, or British Columbia, I should say, and I would single out for women versus men. I would single out the Chinese population.
Oh, okay. Yeah. That is really interesting. Like you do some like personal experiments and then you're like observing about different.
I look at how well they do in competitions and
Wow.
but overall, if you take all the students at UBC, women and men, in first year calculus, there are more female students than male students. That didn't used to be the case.
Wow.
And the female students do, if anything, on the average, a little bit better than the men.
Wow, yeah, I've heard of a study that women actually study harder and they perform academically better than men on average.
Yeah,
maybe.
Probably, but not at the very top end though. At the very top end, males dominate.
Right. If you look at the
males dominate the top end, the males definitely dominate the bottom end.
Yeah. Just wondering if you consider like mathematicians. I mean, these math geniuses are mostly in China, or these very smart
Yes.
math girls. Why do you think currently, regarding like Fields Medal, Nobel Prizes, why do you think it's so conglomerated in the Western countries and so few in the Eastern or Asian countries?
Okay. So, first of all, let's look at the history situation. Don't forget, the amazing thing. Look at China. I'm going to focus on China. Okay.
Okay.
So, because in China, people, I'll use the words in quotation marks, were suppressed. That is until Deng Xiaoping became the leader. Okay. Before then, people did not have freedom, the same kind of freedom to learn and to get a proper education. And then Xiaoping changed things. And in fact, he before, students could not leave China to study before Deng Xiaoping. And then Deng Xiaoping welcomed Chinese students to go abroad. In fact, I had the very first Chinese student at UBC.
Yeah.
As his supervisor. He
Yeah.
was the first one, but he came before the Deng Xiaoping. But he was affected by the Cultural Revolution, this student.
Whoa.
But anyhow, so he had to go. It delayed his education. But anyhow, Deng Xiaoping. People said to Deng Xiaoping, "Why are you letting people from China go freely abroad? Because many will not come back." He said, "That doesn't matter. It's good for the country, people to go abroad." So he gave this freedom and these opportunities. I've had many students and postdoctoral fellows and visitors from China, and I'm so impressed. They came from villages in China and ended up getting a PhD in mathematics.
Wow.
And very impressive that they came from such a poor background, and here they, with no education in their family, and here they got a PhD, and it's I consider that a very important human right. The right to an education and the right to pull yourself up from the poverty into the highest levels, the opportunity to learn. And it was better in China, I thought, than here in British Columbia. the opportunity to learn. I think it's changing now. Unfortunately, it's going in the other way in China now.
Yeah, right.
Now before there were not so many elites in China. Before people were more equal.
Yeah.
But now in China you have the elites.
More communist.
And that's right. The elites want to preserve things for their children. There's only one child. Also, the one child policy led to that too, because you put everything into the one child, and so they want to preserve things for themselves. They don't want to give so many opportunities for people who come from poorer areas. It's harder for someone, I believe, from China today, from a village, to do well compared to someone from Beijing or Shanghai.
Really true.
And I know people I work with make every effort to move, because you have to go to a university in your area in China, more or less. So if you want to go to university in Shanghai or Beijing, you really have to be a resident of Shanghai or Beijing. And many try to become residents there, and that I know, so that their children can go to university in that area.
Yeah. So basically, you think that the reason why we have so few Nobel Prizes like Asians is because China was a really enclosed country, and that is why it affected everything.
You see, if you read the history or the backgrounds of those who won Nobel Prizes, invariably they were students of people who'd won Nobel Prizes. Okay, so it takes time to generate. But the other problem is that there isn't that sort of. Unfortunately, the impression is that in China there isn't that much freedom currently.
Right.
So many of the best from China don't stay in China. The very best.
Right.
And they're in other countries.
I've also heard a lot of Chinese professors or teachers, math teachers, they say that Western countries, they have a higher level academic program, and it's just educationally more superior than what China offers.
I think it's changing. I know of many people, mathematicians, who went to the West and have gone back to China, spend a lot of time in China now. And I believe the opportunities for excellence have improved within China itself.
Yeah, it's good to hear. But yeah. Another question is sort of switching from politics and then math. What's your favorite theorem and why? Over your, I don't know, decades of math studies, what is your favorite theorem?
The word your favorite theorem, you have your own theorems or other people's theorems, you see.
Yeah, maybe give an example.
So if you look historically, in some ways the first significant theorem in mathematics is probably one you used in school, Pythagoras' theorem.
Yeah, Pythagoras.
Go back to Pythagoras if we go back into the earlier times in mathematics. But one of my favorite theorems with respect to my work was actually due to a female mathematician. Her name was Emmy Noether. And her theorem was published around 1918. Emmy Noether, and it's a theorem concerned with. Do you take physics too? Do you take physics?
I'm taking 3 sciences actually, so I'm taking physics.
Okay, so you've heard of conservation laws, right?
Yeah, conservation of energy.
So Emmy Noether was a female mathematician. She gave a theorem about how to find the conservation laws for a system of differential equations.
Wow.
Problems are described by, most physical problems are described by differential equations. So how to find the conservation laws. You're familiar with conservation of energy. Maybe momentum. I don't know if you've heard of conservation momentum.
Heard of it?
Yes, you've heard of it. Angular momentum, those sort of things. So the question is, first of all, what is a conservation law and how can you find them systematically? So that was another more modern favorite theorem of mine. And a lot of my work is an extension of that, with working with others is an extension of that theorem to cover many more real situations than that theorem itself as it stood covered.
Yeah, it's really cool. So,
But in mathematics, there's not just theorems. You see, people formulate ways of looking at things.
mhm,
That's actually the most important thing. Formulating ways of looking at things. That's not necessarily a theorem. Okay.
ways of looking as in perspective, so
Well,
different perspectives.
putting the language to the most important thing is to find the language to describe something and use that description to make predictions. So theorems don't necessarily come from that. In fact,
Mhm,
usually theorems come much later. That is, the theorem arises when you make it more and more rigorous. Okay.
yeah,
But most of mathematics is like other sciences. There's a kind of an experimental aspect to it,
wow, yeah,
where you try things out and then you more and more understand what's happening. That's like every other science. You try something out, and then as time goes on, you understand why is it working, why is it not working, etc., etc.
right. So you're combining math and sciences where it, of course, involves experiments. How about when we have just pure algebraic
No,
math?
no, no, no. So I'm talking about experiment. When we do a calculation in
Yeah,
math, so you got a problem to solve.
uh-huh,
That's like an experiment, trying something out.
yeah,
And then you find a different lines of attack, a good way to solve that problem. Eventually, that will be eventually to become a theorem.
mhm,
But the most of mathematics is the first kind, where you are, which is the creative kind. The creative part is doing experiments with trying things out and then finding patterns and then trying to form a theorem with respect to those patterns that you found.
mhm, yeah. Right. So in your decades of mathematical studies, have you ever experienced, I mean, have you ever experienced any failures and like down
Oh
like,
yes,
no.
oh yes. It is actually one problem that I started to work on. It took me basically 30 years to find a solution. 30 years.
Oh my goodness.
But many things that you do along the way are important to answer the question that you originally posed.
Mhm.
And but failures, you learn more from your failures, by the way. That's for everything in life than you
Right.
do with your successes. But if you have only failures, that's not good, of course. But you still learn more from your failures than you do from your successes, in fact. And it's very
Mhm.
important. So when you fail with something, you got to analyze why did this fail.
Right.
Okay? As long as you analyze it, then that's going to be something. Often something positive can come from that. Mm.
Right. So have you ever made the same kind of mistake like again, like when you went downhill and then you went downhill again, but then
Well, okay. So sometimes you do something and it doesn't work, and you say maybe I made an error along the way, or when it
yeah.
doesn't work, so you do it again. But in fact, it didn't work. Period. You did it over and over again to get the same answer. You see,
Mhm.
so it's a procedure to solve a problem, and it failed.
So when you were probably doing a math observation, were you working with an advisor? And then when you went downhill and then you failed maybe one or two times, was he or she mad at you? Was it very,
No,
very
I was a little bit of an unusual student
okay?
as a graduate student, in that I got my advisors interested in the problem that I was working on.
Oh, kind of like,
Okay.
hmm.
Yes.
It's kind of opposite of what people do. Like you're not working with what the advisor wants you to do, but you're
That's right.
making
That's
him
right.
want to do what you're
So,
doing.
so my advisors never gave me a problem. I got my advisors interested. I had two advisors. I got them interested in the problems I was working on.
Okay, so
I, I
what were
developed
you
I
working on?
developed my own problem. In research, of course, that's what you have to do. You have to develop your own problems in research, making sure it's
Right.
interesting problems.
So it's really, I've heard it's really, really difficult to gather mathematicians together and then work on your particular problem. So, what were your techniques of persuading them?
Okay. Well, first of all, in the case of my graduate school, that was at Caltech.
Mhm.
The supervisor was certainly interested in the areas that I was working in,
Okay.
and they had done something in relation to it, so they were
Mhm.
familiar with it. So they were interested, very interested in it.
Yeah.
So to answer your question.
Right. Another question regarding writing math papers. Which tools do you think is the most efficient way to, like mathematicians, they publish papers and then
Right.
you have to type. It's super tedious, even to
Pardon?
write. It's really tedious to write equations, like typing. So what tools do you use to actually type out equations and then constructing?
Oh, well, there's different software programs for typing the equations. That's the least of your worries in writing a paper.
Right.
It's the content of the paper. That's the work. The content.
Right.
Of the
Right.
paper.
Yeah.
And putting the paper together. That is the work. But the typing of the equations is a trivial part.
Right. So there's like LaTeX, and I've heard it's a really good.
That's right. There's a Microsoft Word has a equation editor, this sort of thing. There's different programs.
Right. So regarding we're talking about typing things or constructing papers. Do you think from a transition from high school to university, the writing is just very, very different? Like one is really formal. You have to, like in university, you have to learn mathematical language, but in high school, you can just write whatever you want. Like a lot of students are having difficulties of getting formal.
I'm gonna stop you for a minute. I hope that's not the case what you're describing in high school, because it shouldn't. To tell you the truth, learning mathematics in high school should not be really any different from learning mathematics at university.
Really?
That's right.
Because at high school, I think in university, your writing is really formal and you have to make sure that everything is so clear. But in high school, it's sort of loose-ended and it's like more chill and it's
Okay, but you'll find it gets progressively less loose-ended at the university as you go on in the years. But the transition from high school to first year, you won't find if you've gone to a decent high school, you won't find a big jump there.
Oh, okay. How about for, as you said, decent high school? Is it specifically from a private high school to a
But we found at UBC that the students, frankly, from the public schools did better than the students from the private schools.
really?
Oh
Why
yes,
is that?
you can see on our website that the students from the public schools have done better. From Vancouver, anyhow, have done better than the private schools on the average.
Wow, that's crazy.
Particularly the ones that have most difficulty are from the boys' private schools.
Like boys private schools like St. George's, if you know that school. Girls. Yeah. It's kind of surprising because I thought that private schools it's more rigorous and you learn more.
No, that's not the facts. Don't you can look at the results in
Right.
first year calculus compared to the high school mark. It's on the math department website actually, and you can see how did the students do, how did their marks change from high school to university, what fraction got passing, what fraction got a first class or A mark, etc. So if you put it all together, overall the public schools do better. And these same studies are in the United States and in Britain too. They show in Oxford and Cambridge. They show that the students who come from the state schools with the same marks do better than the students who come from that does not mean that the preparation is bad from the private schools, by the way. Well, the reason is in fact not at all. What it is that the university environment is more like a public school than it is like a private school. So usually students coming from the high school can be more from public high schools can be more, I think, more self-reliant. They're probably not given as much attention as in the private school.
Right.
And so they have to learn on their own much more. And so that's more like how it is at university, you see. So when a student goes from a private school to any university, then there's a bit of it might be a bigger transition, because we gave students from the schools a test in the first 2 weeks, and the students from the private schools did very well when a test was given to them in the beginning of the course. But at the end of the course, it was not quite the same. The problem is more difficult for boys because coming from only boys' school and then going to university, there's just not boys in your class. There are others too.
Uh-huh.
So we found that we find that schools in general rank students very well, first, second, third, fourth.
Mm-hmm.
And those who come from public school to university, roughly speaking, the ranking remains the same. But from the boys' schools, the rankings change. And so that indicates it's not the school has probably prepared them fine, but the boys have a different environment. And so they are not as serious in their studies.
Okay. So it's the environmental factors.
I would say I surmise it's the environmental factors. Yes.
Right. So talking about math again, Canadian math versus United States math. What do you think is the fundamental difference between math curriculum between these two countries?
Okay. In general, the average student coming out of a Canadian high school is better prepared than the American student overall. Because in the United States, it's a social thing. Because in Canada, in every province in Canada, teachers are paid the same in every school in that province.
Mm-hmm.
Whereas in the United States, it depends on the local tax. So therefore, those kids who go, I'm talking about public schools now, but those kids who go to schools where the people are poorer, so that means that they pay less taxes, the schools don't get as good teachers.
Oh.
So that's the main reason for the differences between Canada and the United States, is the way how schools are funded.
Right.
So the students who go from very wealthy areas, they have very good schools in the United States. But there's the relatively speaking, there are more going to poorer schools than going to the very wealthy schools. Okay.
Wow.
So that is the main factor, though, is the way schools are funded, and that's really a question of the nature of the societies. Canadian societies are different. We have a more equal school. We have more equal medicine, right?
Right.
The two
are related.
Are related.
Mm-hmm. Yeah. Well, I would say the wealth disparity in the U.S. is like greater compared to the wealth disparity. Like,
yes, but in the United States, it's made worse by the fact that you don't pay for the schools by the state. It's paid for by the local school board in the United States. You see, whereas in British Columbia, all provinces in Canada, it comes from the provincial government funding. So it's equalized. It's more equalized. This is very important. Very, very important. It's a profound effect on the society.
Right.
And this propagates to people as they get older. You have roughly speaking, a rural-urban split you have, and this leads to the polarization that you have. Much more polarization in the United States compared to the polarization in Canadian politics. Has a lot to do with the education, how the education is funded.
Right. I've heard
people.
Yeah. I've heard people say that the US, maybe the best schools in the US, they teach math is like taught at a deeper level than Canadian schools. Do you think this is true?
A lot depends. I think there are, well, first of all, the United States is about 8 or 9 times the size of Canada in population. Okay. But so you have to look at it that way. But yes, as a matter of fact, I have worked with teachers in Canada, from all across Canada, and I've worked with teachers from all across the United States, separately. High school teachers, I'm talking about. And so yes, so they are some truly excellent schools. In fact, they were set up. There was a Bronx School of Science in New York. It's a very famous school. There was one in North Carolina. These are public schools, truly outstanding, where they group together the very best in New York area in one school, etc. It's not quite as pronounced these days as it used to be. I tried to get something like this in British Columbia. I went to the Minister of Education to discuss this. I was hoping to have a central public school in the central part of Lower Mainland, which would be excellent for those who are very seriously whether it be the arts or the sciences, and bring together. That's what they do in these top American schools. They bring together the best students. It's an opportunity, but there was a great opposition to that. Great opposition.
And why do you think is the reason?
Because they wanted things to be, quotation mark, more equal.
Right. Yeah.
I think that's not correct. I think you should give, the most important thing in education is giving your kid as the maximum opportunity to learn. And let the parents and the child together decide whether they would take advantage of the opportunity to learn. But you got to provide the opportunity, though. And the most important thing in education is providing the opportunities to exceed, to excel.
Right. And talking about the educational math programs, so as you've been to China before, China is like communist, everyone's equal. Why do you think?
It's not equal now. Oh, no. It's far from equal nowadays. Far from equal.
Right. Why do you think they make the math so difficult, but compared to Canadian mathematics?
Okay, that's a good question. It's a very good question. As a matter of fact, when I was in Shanghai, I'm more familiar with Shanghai than other parts of China, first of all.
Yeah.
But I can make an observation about Shanghai. In fact, in my trips to Shanghai, they actually changed things along the way. But anyhow, because things in China are not static. They do involve the education in China, quite markedly. But anyhow, in Shanghai, I was presenting things to the professors and the students of a first-year calculus class in Shanghai, at a university in Shanghai. And then I found out, and I went to other universities, more than one university. I've been to probably a dozen in Shanghai area. But anyhow, I found out that the same textbook in first-year calculus is used in every single university in Shanghai. And at least the last time I checked was about 6-7 years ago. And every single university has the same, in Shanghai, has the same textbook. And it makes absolutely no sense because they do not give good explanations. They're designed for students. First of all, they have a very strong emphasis on, I would call, rote learning. In that
foundational
book. And so the students don't, although they are getting at a so-called high level, they don't really understand it. That's what I found. The students did not understand what's in the textbook. Maybe at the very best universities in Shanghai, maybe in Fudan, for example, or Tsinghua, they would understand. But the same textbook is used at Shanghai Institute of Technology or whatever other university you can name in Shanghai. The same, roughly, there are more than 100 universities in Shanghai.
Yeah.
But the same textbook, and the students are very different. In fact, to go to the top universities, there's a very strong selection process to go to the top universities in Shanghai. And yet they have the same textbook. It doesn't make sense.
Really doesn't.
No.
Right.
Maybe it's changed now, but I'm going to guess that it hasn't changed, but I don't know. But there are attempts in China to make it more open, the teaching. In fact, I was asked to give lectures for that purpose.
Right.
Make it more open.
So there are lots of Canadian students who are super interested in math. How do you think, what should they, okay, for example, they're only in grade 8 or 9 or somewhere in high school, and they just somehow, they finished like all the math courses or requirements or APs that are required at this high school level. What do you think they should do to further develop their math knowledge?
Okay. Well, I had this problem myself when I was in high school.
Yeah.
But anyhow, well, you have one huge advantage these days. You have the internet.
Yeah.
And I did something in my last years of teaching. I'm an emeritus professor. I was teaching a first-year calculus class in my last year, often the honors class. I would teach the honors class first year. And I was observing that the students were learning a lot. As they just come from high school, they learned a lot from the internet on their own.
Wow.
And so what I did, I decided that I'd do an experiment. I would give an extra 2 hours of voluntary classes to my students. They were not involved with the coursework.
Okay.
They were not compulsory. You could just come there, and what these hours were, you could ask me any question in mathematics or physics. You could ask me any question you want, and nothing doesn't have to do with the course.
Okay.
And sometimes, often, I couldn't answer the question, but I could tell the student, "You go see, read so and so, go see so and so person,"
Okay.
and etc. And through that, I also learned what the students were reading themselves. Have been reading themselves about different things,
Mhm.
but a lot of the things they were reading were only buzzwords. They didn't really understand it. And so what we want to do is I think education needs to evolve, that the teacher becomes a resource person.
Right.
But that means the teacher has to know the subject matter very, very well, and has to know many, and in knowing it very well, they need to be able to explain it in many different ways.
Well,
That's
there
part of
is
knowing it well. That's part of knowing it well.
right. There is a problem with this high school math program. I mean, a lot of math teachers, even I've been to both a public school and a private school, and the math teachers, like there's a PE teacher, they teach math 8, math 9. They don't know anything. And then maybe they only know the very a shallow level of math, and they teach
Yes.
math 12. Do you think this is an okay
No,
situation?
no, a terrible situation. Let's see, in China, that would not ever happen in China. In China, even at grade 1 in China, they have a specialist teacher for math. In grade 1 in Shanghai, they would have a specialist teacher in grade 1. And the teachers teach fewer hours in China than here. They have offices like in universities in China, and the teachers have professional development. The math teachers get together, great in elementary schools, to discuss mathematical things. So that's a very good thing. The elementary program is very good in China. I should say Shanghai.
Yes.
But so what you're saying is a very, very important question. As a matter of fact, I'll tell you, this may sound like a paradox, but they made a survey of teachers of mathematics about how easy is it to teach mathematics. And the less education in mathematics a teacher had, the easier they found it to teach. Because, and what you start thinking about it, why? Because they don't go into any depth. It's very superficial what they're doing, you see. So the more you know the subject, the more you appreciate the nuances and the importance of different things in the subject.
Right. Another problem that I've noticed about this math education that is quite prevalent is that teachers don't explain the derivation of a theorem. They only explain the variables. So when you're solving problems, you know which numbers to plug into that theorem.
But a good teacher wouldn't be that way. A good teacher would be able to explain.
Right.
There's a good knowledge of math. As I said, in some countries they require teachers to. It's a very well-paying job, and they're required to have the best example is Finland. By the way, they have teachers are very well trained in the subject, and they paid very highly in Finland. In fact, in most European countries, teachers are paid better than here. And it's a scandalous how low the salaries are for teachers. And they don't earn enough respect either, the teachers, in my opinion. So some of the very good, all the teachers we have actually overall a fine set of teachers, but there's not enough respect for the teachers, and that's a problem we have. And so we need more excellent people. Not that the people who aren't going to teaching are not excellent right now, but we need more of them to go into teaching. More people, specialists in subject areas, to go into teaching. And we need to have standards, like you are saying. It's important that a person who's teaching grade 8 up math has a degree in math. That's very important. But I think it's only a minority do, a small minority. A minority only have that situation, are trained in the subject matter. And in most countries, you are required, even in most states in the United States, you're required to have a degree, or at least a minor degree in the subject, to teach it. But in British Columbia, if you got a teacher certificate, you could teach any subject.
Right. That is a big problem.
The big problem, and the biggest problems in elementary schools, because up to grade 7, so that they may not have any specialist math teacher in the whole school to help other teachers. Because some teachers, we found at UBC that the main reason, I did a study once at UBC as to who was becoming an elementary school teacher. And they were the ones who had the least math.
That's crazy.
Because there weren't very many subjects. And UBC only had grade 10 math for admission at that time. Grade 10.
Wow.
So I went to UBC and said we got to change at UBC to at least grade 11 math.
Mm-hmm.
That was done. And the main reason for change was to make sure that those who went into becoming elementary school teachers at least had grade 11 math background. That was the motivation for the change.
Right. Is really, really important. Even teaching math 12, the teacher does not specialize in math, maybe in computer science, and knows a little bit of math. And
that's not good. It should
right.
be a person who specialized in math, at least a minor in math.
Right. And I think maybe, do you think that we, like Canadian citizens, can report to the BC Ministry of Education and change this whole societal
yes. By the way, I was involved with a quotation mark Chinese society in Vancouver called Quest, and they were trying to get changes. I had a criticism for the group. I used to give talks to the group. I was the only non-Chinese person present, you see. And the meetings were often conducted in Mandarin.
Oh.
But anyhow, I told them they have to branch out. You can't just, if you're going to make changes, you have to bring in other communities, not just the Chinese community, because the school system has other people in it, not just Chinese people in it.
Right.
So, but that, I don't think it went on there, because you don't get very far unless you get a broad-based group pushing for education change. But I was pleased to see that I don't want to be political here, but I'm going to be slightly so. I was pleased to see that I was very upset in Vancouver when the school board, maybe you heard about that, eliminated the honors courses in a couple of schools.
Right, yes.
And I was very impressed that the students from the schools, from 3 different schools, went to the school board, made a presentation, an excellent presentation. Everyone should see it. It's on the web. Right. An excellent presentation to the school board about, please don't do this. But I was so disappointed. They didn't get one. They made a fantastic presentation, but they didn't get one question. They were completely disregarded. I was so sad. But I'm pleased to say that almost all those people who were present, who were on the school board, did not get reelected.
Yeah.
And because it's to disregard students who come in front of the school board and make a presentation on such an important issue, and to ignore it is terrible.
Right. I think the Canadian math education could change a little bit, because I think there's honestly high school math and then university math. Would say there is a gap, actually, because high school math is much more simpler than university level math, because it's way more in depth and way more theoretical. And I think that there has to be some sort of a transition, maybe 1 year.
Well, I don't agree with you, really. I think it depends on the school and the teacher you have. And by the way, you're only in grade 11. It's grade 12 when you 11 goes to grade 12. It's grade 12 that goes to university. Right. So I don't think you're quite in a position to say that until you've gone through grade 12.
Well, I actually completed all my high school courses, and I think
you did. Okay, I apologize then for that. But what I do find, I've worked with so many teachers from British Columbia over the years, mathematics teachers, and there's some very, very fine teachers who teach their students in depth. You can see from the math contests, those schools that do well in the math contests, and they are the ones who have teachers who really teach in depth. Otherwise, the students would not do well in the competitions, which are based on the school curriculum.
Right. Speaking of math competitions, what do you think is the fundamental difference between school-taught math and plain math competitions? And do you think math competitions are necessary for your mathematical development?
The math competitions, like the Euclid or for example, they are really based on the school curriculum. So they're very important, in fact. And especially in the fact that we don't have a provincial exam. is terrible that there's no provincial exam in mathematics.
Yeah.
And there used to be not only provincial exam in mathematics, but an honors exam in British Columbia.
Yeah.
But now there's nothing. And this is not good at all, because provided you have a good provincial exam, that can upgrade the math attainments in the schools.
Right. And what do you think was the reason behind this cancellation?
Oh, okay. I used to be on the provincial board of examiners, by the way.
Mm-hmm.
Member of the examiner board. Anyhow, the reason was, and is I can't go into. Unfortunately, I cannot give you the real reasons, because we met in camera. You know what that means?
Right. Yeah. Yeah.
We met in camera. So I can't say what went on, because we were the committee I was on was advising the minister.
Okay.
But it's not pleasant to say. That's all I will say.
Okay. I mean, I've heard from other people that teachers are too stressed out, and then they need a break, and then.
Oh no! The teachers of math were overwhelmingly in support of a provincial exam. Overwhelmingly.
Oh, because they said they don't want to be marking someone.
I have the information. I surveyed the teachers in British Columbia about this question.
Yeah.
So no, they were overwhelmingly for it. The mathematics and physics teachers were overwhelmingly in favor of provincial exams.
Wow. Do they get paid for marking so many?
They got the government didn't want the one thing that government didn't want to pay extra money for marking. That's
Mm-hmm.
the amount of money it costs for the exams is a pittance compared to what the education costs are.
Right. Mm-hmm. So, like, you know how math is like a tree with lots of branches. There's so many fields.
Yes. Mm-hmm.
What branch do you think might just stop developing in the next 100 years?
Oh, I am not a soothsayer. And I'm using the word soothsayer here because that means it's kind of a witchcraft almost. but so neither as a soothsayer or as a scientist would I be able to answer that question. But things do evolve over time. What areas of mathematics? The biggest area is still differential equations in mathematics.
Right.
A single area. But there's different areas becoming important as time goes on. Computer science, developments of computer science affect the areas of math that are important, for example.
Mm-hmm.
So discrete math is very important for the computer science direction. But you'd be surprised what an area of math that at first was thought not to be important, later on becomes important as developments occur. So it's very hard to predict, which areas of math. More importantly, is that the skills you learn in doing math will often transfer over into other directions, or in other words, even new areas of math or other things. But you have an open mind to going in different directions. You got a good broad-based background in mathematics.
Right. Do you think there's a fundamental difference between applied mathematics and theoretical mathematics? I've heard some people say they just merge together into one, and they're probably.
I'm a mixture. I am personally a mixture of the two.
Right. That's great.
But first of all, you have to give. It's hard to define. So sometimes, so-called pure mathematician becomes the field becomes very important. For example, and a very important area is cryptography.
Mm-hmm.
Security codes, this sort of thing.
Right.
And that's an outgrowth of an area of mathematics which is very pure, called number theory.
Mm-hmm.
And until we had these security things, number theory was not considered that important. Okay. But now it's a very important area.
Right. And because we have our society is evolving through technological development. We have
That's right.
Elon Musk.
That's right.
Robots.
Oh yes, so robots are connected with mechanics and whatnot.
Right. So do you think we
need another thing is, I'll give you another example where mathematics has changed things is in Hollywood. In Hollywood, for all of the cartoons, or the yes, what do you give the names of the movies that are cartoons. I don't mean cartoons, but full-length movies, which are animations. Animation.
Yeah.
I'm sorry, animation. So animation used to be done by people drawing and flipping things, shall we say, from one drawing to the other. But now, all the movies that they have scenes of water moving. It's to become, as time went on, the graphics and the animation become much more realistic with time.
Yeah.
Because they've switched to, now the graphics is based on differential equations. They actually use differential equations and hire people who know differential equations to model, to design the animation, and they like it for two reasons. The producer directors or the movie studios, because it's cheaper. Secondly, more reliable. They know what can be done in that particular period of time. You see,
Right.
It's a matter of solving the differential equations. For example, the main differential equations for fluid flow, are what's called the Navier-Stokes equations, and it's solving that. And usually use a numerical solutions are used to then convert it into animation.
Right. So math really applies to current society.
In fact, the head of the computer science department at UBC was such a person working with the movies and animation.
Canadian, yes.
Yes.
Shout out to Canadian universities. It's really good. The best minds in the world. Regarding how you said how we have differential equations producing wonderful animation images. So why do we need mathematicians right now? Will they be replaced by robots one day?
The word robot, you don't mean the old Hollywood robot or someone
like AI, artificial intelligence,
robotic machines. Okay,
right.
So you're really saying, will a software package replace a mathematician? That's your question, really?
Right.
But someone's got to make the software package. So the actual situation is that because of how things have developed technologically, the mathematicians are much more used than before. The opportunities are much greater for mathematicians than before.
So, I mean, mathematicians
are making the robotic packages come from mathematics. Okay.
Right. What if a mathematician developed a robot and then
you're talking about there is a lot of discussion about that, robots making robots.
Right.
And so, but you still got to go back. There's always a beginning of the universe, right? Keep on going back, you see. So it still comes down to the fact that unfortunately the other jobs become more irrelevant than the mathematician jobs.
So I would say humans are overall more creative than robots.
That is, something's got to drive the robot. That's right. You got to go into that. But again, there are people talking about machine learning, as you say, machine learning, artificial intelligence, the big data science. Those are the big buzzwords these days: machine learning, artificial intelligence, and data science. So many mathematicians are in these directions: machine learning, artificial intelligence, data science.
Yes. So
data science means big data, using big data.
Right. Even though no one can predict the future, or no one can. It's a personal question. Over the next 1,000 years, what progress do you expect to happen in this mathematical industry? Like, do you think this might develop or that? Any changes that you think?
Well, we are becoming more automated with time. And and automation is often controlled by software.
Right.
So we're going to be more and more people are going to have to be in that kind of direction with time, as it's happening, where the jobs are. And but I wouldn't want to predict what will happen. I'm afraid we can't predict what's going to happen in the future. But it does look like areas like data science, artificial intelligence, machine learning, and machine learning is connected with what you are talking about, are going to become more and more important. And the people in mathematics with their kind of background are usually adaptable to change, or readily adaptable to this kind of a change.
Right. And do you think one day in the near future, when we just have too many robots operating, do you think it is somehow a dangerous situation?
Oh, very much so. In other words, the robots become so intelligent.
Yeah.
Okay, I use that word, artificial intelligence,
Mhm.
and so that the human being looks small. The real problem is going to be that the number of people who understand the picture is going to be tinier and tinier as
Mhm.
time tinier until things are more specialized, shall we say. So it makes us all feel very uncomfortable, right? That we can't understand things. We have to take these things for granted. And that's part
Mhm.
of a lot of the anxiety in the world is based on that these days. In fact, the fact that
Right.
we don't feel in control of the situation. We depend on experts, and therefore we don't like being dependent on experts. So that's not. Therefore, we will disparage experts. This a
Mhm.
lot of disparagement of experts going on in the political arena these days.
Right. So as a last question to end off, do you have one or two particular books that you recommend for high school students or listeners around the world to look into, like for fun, math books?
Oh, okay. Math books front, or do you want? There's a um, there's a book for high school students to read about what an exciting book to read about a mathematician is a book by Leopold Infeld.
Mm-hmm.
I think it's called Whom the Gods Love.
Okay.
And it's about a mathematician, a French mathematician, Évariste Galois. Have you heard of him?
No, I would love to look into that.
Yeah. So Évariste Galois developed a mathematical framework which proved certain things. It proved that you could not trisect an angle by ruler and compass, for example,
Mm-hmm.
or you could not give a formula for a polynomial equation of degree greater than 5. No such formula would work for all polynomials,
Mm-hmm.
an exact solution. They were all spin-offs from the work that Évariste Galois did. And he did this work when he was 20 or 21 years old, approximately.
Yeah.
And he had sent his work into the leading French mathematicians of the day, Lagrange and Laplace and people like that, and they ignored it. Anyhow, he was infatuated with a young lady, and someone else was infatuated with the same young lady, and they
Oh,
and they had a duel, and
oh, wow.
he didn't survive it.
Wow.
So anyhow,
Okay.
it's an interesting story to read about this Évariste Galois. It's written for really at the level of high school students.
Mm-hmm. Yeah.
And the same Leopold Infeld who wrote this book, he worked with Einstein and wrote a book, by the way, in physics together with Albert Einstein for the public.
That's crazy. Wow.
It was a bestseller for many years back in the 1930s. But anyhow, he also wrote another book about what it is like to be a mathematician. It was an autobiography that he wrote,
Okay. Yeah.
and he wrote this at a relatively young age, but it's the best book I've seen. The Galois book has got some fiction in it, a little bit of fiction in
Mm-hmm.
it. But
Mm-hmm.
this book is about, if you want to learn about what it's like to be a mathematician or a physicist.
Yeah.
He was a mathematical physicist. He ended up in Canada. He was in Toronto, University of Toronto, for a number of years as a professor. Anyhow, but he's originally from Poland,
Mm-hmm.
and and then he was working with Einstein. He was Einstein's mathematical assistant, shall we say.
Wow.
But anyhow, he wrote these two very good books, which I recommend to students. One about what is it like being a mathematician,
Yes.
it's
Mm-hmm.
not autobiographical, and the other one is about Évariste Galois.
Mm-hmm. It's great. These books are reading is always good. But
Mhm.
thank you so much for answering my questions.
Very welcome.
Yeah.